Hello viewers, welcome to Big Boy Physics. In today's video, our topic is polar coordinates. Okay, so I am covering it in the basic maths portion, but I'll be using some kinematics relationship. So if you want to know more about this topic, you can refer to David Morin or Kleppner Kolenko, whatever you want. You may get them in the Newton's laws of motion section instead of kinematics because that's more related to dynamics and pseudo forces instead of kinematics, especially the acceleration term. Okay, so yeah, this will be some Olympiad related concept and may not be much useful for GE. So just this is the kind of a warning before going proceeding the video. Okay, so let's get started. Polar coordinates. I must have briefly said you about polar coordinates that we take two axes. The we do not define them to be y-axis or x-axis, but instead of writing the x coordinates and y coordinates as the position term, what we represent that if there is a particle, suppose the red dot p represents the particle. Okay, then the vector connecting this origin O to point P has length of r and its angle making with some fixed axis which is representing by x-axis is theta. In this case, we assign two vectors. First is r cap along the OP direction, another is theta cap perpendicular to the OP direction. But one thing to note is that this theta cap, if we try to swirl our hand by taking the, what can we say, this theta cap will point in the anti-clockwise direction. Basically, if we put our hand on the origin and swirl the palm, okay, swirl our fingers along the theta cap direction, it will come out in the anti-clockwise direction. Okay, so yeah, we represents two axes, that is r cap and theta cap. Okay, I hope you get it. Now, to represent the positional coordinates of point P, we represent P to be P or r vector is equals to r cap. Okay, now the position of point P is given as r vector, which is given as r cap. If it was in case of Cartesian system, what we would have written, r vector is equals to r cos theta I cap plus r sin theta j cap, right? Now similarly in polar coordinates, it's really simple to write because it's just r cap. I hope you understand it. Okay, so now what will be the velocity? Velocity will be dr vector by dt, which will come out to be d by dt of r cap. Now for now, suppose that d by dt of r, that is the magnitude of change of the magnitude of radial vector, is given as r dot, and the rate of change of the magnitude of rate of change of radial vector, that is dr dot by dt, is given as r double dot. Okay, now observe that it is written as product of two components. First is the r and second is the r cap. So using the derivative rule, that is product derivation, then we can say r cap dr by dt plus r dr cap by dt. Hence, if we simplify it, we'll get r cap r dot plus r dr cap by dt. Right? Now, how will be writing the dr cap by dt? Now this is a question to arise because this writing this dr cap by dt is a little harder, rather I can say. Now we can say something like this. Suppose initially my coordinate system is somewhat like this: theta cap, this is r cap. All both of them are unit vectors, you know. Now suppose that the particle has gone in such a way that the angle has rotated from theta to theta plus d theta. Then this coordinate system will simultaneously rotate by some angle d theta again, and this r cap will point in the some other direction and theta cap in some other direction. Okay, so I can say that this to be dr cap direction and this to be d theta cap direction. So I can say that d theta cap is equals to theta dot d theta. Okay, and this, observe that the direction is along the r cap direction, but the negative sign, we know that d theta cap is pointing in the opposite direction to r cap. So I can say that d theta cap is equals to minus d theta r cap. Now dividing it with dt, we know that d theta by dt is omega, or we can write that d theta by dt is equals to omega or theta dot. Likewise, we did in previous case for radius vector, length of the radius vector we dot r dot. So in this case also we are writing the rate of change of magnitude theta is written as theta. So I can say that theta cap by theta is equal to minus r cap theta dot. Similarly, dr cap by dt is equals to d theta by dt into theta cap, which will come out to be theta dot theta cap. Hence, I can say this velocity vector is equals to r cap r dot r cap plus r theta dot theta cap. Okay. So yeah, I hope you get it. So in this derivation, we'll be using the vector calculus or derivatives of vector also to make you understand the relation of polar coordinates with velocity, acceleration, rest of everything. Okay. So this was the expression for velocity. It was clear cut and easy to say because you already derived the expression for velocity previously also. It's just superposition of the r theta dot and r dot. So just we have done the same thing. But writing the acceleration is not as easy as writing the velocity. Let's hop on to acceleration. So this dv vector by dt can be written as r double dot r cap plus r dot dr cap by dt plus r dot theta cap. Now this is a triple derivative. Observe that this next term, I'm not opening it right now. This is written as somewhat like this. Observe that this is a really a big expression. In this derivating, instead of fg, like we use dfg by dx is written as f dash g plus g dash f, where f dash is written as df by dx and g dash is similarly written as dg by dx. But in case of dfgh by dx, what we do is that we take f into gh as one function, f as one function and gh as another function. Then applying the uv rule in the first portion between these two, I'm marking first between these two, then second between these two, this f and g. And in this case we'll be arriving to a result that is f dash gh plus f g dash h plus f g h dash. So this will be the final result which will be coming after finding the derivative of f into g into h. Okay. Now, before proceeding, let's write dr cap by dt, which will come out to be theta dot theta cap. And finally, opening this d by dt of r theta dot theta cap, we will get it to be r dot theta cap plus r theta double dot. So, theta double dot is again the same thing I explained previously, that is the derivative of magnitude of theta dot. So you'll get r theta dot theta cap double dot r theta double dot theta cap plus r theta dot, what is d theta cap by dt? D theta cap by dt is written as minus theta dot minus theta dot. So what is d theta cap by dt? I previously derived minus theta dot into r cap. So it will be r cap another. Hence the final result which will be arriving with as 2, sorry, it's not here right now, I'm just doing the simplification of this term. So I get r dot theta cap plus r theta double dot theta cap plus minus r theta dot square r cap. Okay, the result will be somewhat like this, and adding both of them, the answer which will be getting is dv vector by dt, that is acceleration vector, is given as r double dot minus r theta dot square r cap plus theta cap 2 r dot theta dot plus r theta double dot. So yeah, that's the final answer. Now these components I'll be explaining them one by one. So this r double dot basically represents the acceleration along the radial direction. Okay, the rate of change of the radial velocity, you can say. Okay, so if this is the length, Then the rate of change of this length is given as r double dot. Now r theta dot square, this will be somewhat familiar, will be, that is the centripetal acceleration. Okay, this is called the centripetal acceleration. So this is the components along the radial direction. Now in the theta gap direction, first one component is this r theta double dot, that is the acceleration due to the virtue of angular acceleration. Okay, so this acceleration is due to angular acceleration, and this term 2 r dot theta dot is actually, some you can call it as a Coriolis acceleration, but it's better to pronounce it as, while writing the pseudo force equation we use some Coriolis force. So this component basically comes with that. Okay, to get your feel, I'll be giving you an example. Suppose you have a table, turntable, and there's a block on it. Now if you rotate the turntable, you observe that this block will be pushed away. Of course this block will be pushed away, but observe that as it gets pushed away, then the velocity, the radius changes, but assume that this turntable is moving with constant omega. This implies that even if the radius is changing, the velocity increases. Now in this case, there must be existing some normal. There must be some normal, otherwise this is not possible. So this normal actually produces some force which indeed increases its velocity along the tangential direction. Yeah, if you want to think about r theta double dot, this theta double dot is 0. This implies that the acceleration in this case is given as r2 into r dot theta dot, that is 2 into vr into omega. So this is the acceleration of this block in the tangential direction. Hope you get it. So in this video, I just covered about the theory. And before quitting, I want to remind you another thing, that for rigid body dynamics, this r dot term is basically zero. Why r dot term is zero? Because when you take two particles on this rigid body, we know that this body is rigid. Rigid मतलब ढीठ. Rigid body मतलब ढीठ होता है. I am also explaining in Hindi. Don't mind. Okay. So if it is a rigid body, will it allow any change in the distance between these 2 points? It will always be fixed with time, space, coordinates, whatever you think. Okay. Yeah, for rigid body dynamics, we can see clearly that this Coriolis term will cancel out to be zero. And yes, we'll be applying this in a lot of problems in the upcoming videos. Okay. So that's it for today. Hope you stay tuned and watch the next videos, because next videos will be based upon problem solving of this concept, especially focusing on the term acceleration. Thank you. Have a nice day.